Tonight's presentation is titled Diagnosing High Oil Consumption, and our presenter is Mike Bush. Mike is the president of Savvy Aircraft Maintenance Management Incorporated. Mike holds a Certified Flight Instructor certificate. He's an author for numerous publications, including the EAA Sport Aviation magazine. Mike holds an A&P certificate with inspection authorization and was honored by the FAA as the Aviation Maintenance Technician of the Year in 2008. Mike's an EAA member, and we're so happy that he's with us tonight. Thank you so much, Mike, for volunteering your time to share this valuable information with us. I'm going to turn control of the presentation over to you.
Okay, and the subject that we're going to talk about tonight is diagnosing high oil consumption. It's one of the very most common kinds of engine issues that we have owners report, and frequently the cause of oil consumption is misdiagnosed, resulting in owners spending lots and lots of money on things that aren't going to fix the problem. And I will start off by talking about an actual diagnosing problem that started when a fellow by the name of Ted gave me a phone call, and Ted flies a 1984 Cessna T210. The airplane was in annual inspection at the time that he called me, and he had told his A&P that his oil consumption had risen a lot. The engine used to use a quart in 8 to 10 hours, and all of a sudden it was using a quart in 3 to 4 hours. And the A&P replied that the aircraft probably needed a top overhaul, that it was very rare for turbocharged Continental engines to make it to TBO without a top overhaul, and recommended that Ted do that. A top overhaul, of course, is replacing all of the cylinders on an engine, either by pulling them off and having the cylinders overhauled, or by replacing them with new cylinders. And the mechanic gave Ted a quote for doing this of $14,000. Ted had been reading my articles in Sport Aviation and so on, and knew that I wasn't a big fan of top overhaul, so he decided that before he approved having the mechanic do this rather expensive surgery on his engine, that he would give me a call and get a second opinion. So I counseled Ted not to do anything rash. That when faced with a situation like this, it was good to slow down and go through a thoughtful and comprehensive a diagnosis process to try to get a handle on exactly why the oil consumption had increased. I pointed out to Ted that oil consumption of a quart in 3 or 4 hours is high enough to be of some concern. We definitely want to get to the bottom of why the oil consumption increased, but it's not yet at the point of being any sort of a safety of flight or airworthiness issue. If you call Continental Tech Support, and this airplane has a Continental TSIO 520 engine, Continental will basically say, don't bother us unless your oil consumption is a quart in 2 hours or worse. And actually, if you look up the type certificate data sheet on this engine, maximum oil consumption is about a quart per hour. Now, I don't think any owner would want to let the oil consumption get up to as high as a quart per hour, simply because it's very embarrassing to run out of oil before you run out of fuel. But the sump capacity of this engine is 12 quarts. It will run just fine down to as low as 4 quarts. Typically, owners try to keep the oil level up around 10. So the oil, even at a quart per hour, it would be kind of hard to run out of oil before you ran out of fuel. In any case, I wasn't suggesting that he let things go that far, but I was pointing out that he didn't have a gun to his head and didn't really need to deal with this problem instantly. So I suggested that we do a little troubleshooting to try to to get to the bottom of why his oil consumption had increased before he made the decision to throw $14,000 at the problem. Now, anytime we're diagnosing oil consumption, the very first question that we have to ask, the very beginning of the diagnostic tree, if you will, is the question, where's the oil going? If the engine is losing a quart every 3 hours, how is it losing it? Where is that oil going? And there are only three possibilities. It's either going out the breather and winding up on the belly of the aircraft, or it's leaking out of the engine somewhere and making a big mess in the engine compartment, or it's actually getting into the combustion chamber of one or more cylinders being consumed in combustion. And so we need to determine which of those three was the reason that Ted's engine was using a lot of oil. How can we tell which of these three is the culprit? Well, that's pretty easy. If the oil is going out the breather, then there's going to be a bunch of oil on the belly. If the if the oil is going out of some sort of leak in the engine compartment will be an oily mess. And if it's being consumed in combustion, then the inside of the tailpipes, instead of having a nice dry powdery residue like they should have, will have a dark sticky oily residue on them, and that's sort of the telltale that oil is actually getting into the combustion chamber and being burned in combustion. And all you need to do is run your finger around the inside of the tailpipe and see what the residue feels like and what it looks like. So it's pretty easy to decide which one of these three are the case. So if the cylinders were actually worn and this engine actually needed a top overhaul, then there'd be lots of oil on the belly, because that's when cylinders wear out. We get elevated blow-by past the rings. We get crankcase pressurization, and that causes the oil mist that fills the crankcase while the engine's running to be blown out the breather and wind up on the aircraft belly. So I decided it was probably time to play 20 questions with Ted and see how much information I could gather over the phone to try to see if we could get a handle on what his oil consumption problem was. So the conversation went roughly like this. I said, Ted, are you seeing a lot of oil on the belly? He said, no more than usual. I said, are you seeing a lot of oil in the engine compartment? He says, not really. The engine compartment looks dry. I said, is the inside of the tailpipe dark and oily, or is it light and dry? He says, well, now that you mention it, the tailpipe does look rather dark and oily inside. I said, well, I think that's a smoking gun. We've established that the oil is getting into one or more cylinders and being burned in combustion as opposed to being blown out the breather, which is the most common reason for oil consumption, or leaking out of the engine and making a mess in the engine compartment. So we got our first question pretty well answered, that the oil was getting into the combustion chamber. And now the next question is, how's it getting there? Now, again, there are three possibilities of how oil gets in a combustion chamber. A possibility one, which normally would happen in a normally aspirated airplane, is that it's being sucked into the combustion chamber through a worn intake valve guide with a bad intake valve oil seal. The top of the cylinder, the rocker box area, where the rockers and valve springs and so on are located, is all full of oil when the engine is running. And if the intake valve oil seal is not sealing well, and if the intake valve guide is kind of worn so that there's some space between the valve stem and the valve guide, then oil can get sucked from that rocker box area into the cylinder and get consumed in combustion that way. Normally we can determine that that's happening and figure out what cylinder or cylinders it's happening in by doing a Boroscope inspection. If you take out the top spark plug, stick a Boroscope in the cylinder, rotate the prop so that the intake valve is fully open, and you can get a good look at the valve stem as it's coming out of the valve guide. That stem should be nice and dry, and if there's oil on it, then you figured out how the oil's getting in there. It's getting in there through the valve guide. Now this wasn't very likely in Ted's airplane because it was a turbocharged airplane. And in turbocharged airplanes, the cylinders don't suck air into the combustion chamber. The air is being blown into the combustion chamber by a turbocharger. So it's unlikely in a turbocharged engine that oil would get in this way. In a turbocharged engine, the most likely way that oil can get into the combustion chambers and be consumed in combustion is that the turbocharger is leaking oil into its compressor and blowing the oil into all of the cylinders. The turbocharger has a center section which is lubricated by engine oil, and then it's got a compressor on one side and a turbine on the other side, and there are oil seals that prevent the oil that is being pumped into the center section of the turbocharger from leaking out into either the hot section or the cold section of the turbocharger. But if the oil seal is bad, or if the scavenge pump is bad, the scavenge pump is an auxiliary oil pump that is on all turbocharged engines, whose job it is to suck the oil out of the center section. And if the scavenge pump is bad, or the oil seals in the turbocharger are bad, then oil can get into the compressor and get blown into all of the cylinders. And the way we find out if that's the problem is simply to inspect the compressor of the turbocharger. It should be absolutely dry. There should not be any oil whatsoever in there. And if we start seeing oil in the compressor, we know what the problem is. There's actually a third possibility that can happen in any engine, whether it's turbocharged or not, and that is that we can get stuck rings in one or more cylinders that are stuck typically because they are fouled with lead sludge. And if the rings are stuck, then it's possible for oil to get up into the combustion chamber past the rings. And the way we normally find out if that's the problem is we do a procedure called a ring wash, where we fill the combustion chamber up with a solvent, and then put a top spark plug back in, seal up the combustion chamber, and rotate the prop to force the fluid past the rings. And in a ring wash, you can basically tell from the sound of that fluid washing past the ring packs whether the rings are fouled or not. And if they're not fouled too badly, the ring wash can actually correct the situation by forcing the lead sludge out of the ring grooves and restoring normal ring operation. If the piston is sludged up too badly, you may not be able to do that, and you may have to pull the cylinder. But in any case, there are three ways that the oil can get into the combustion chamber. So I went back and started asking Ted about that to try to see if I could find out how the oil was getting in there. And I asked him, I said, Ted, are you seeing any oil in the vicinity of the turbocharger? And he said, well, yeah, there's actually a small oil drip that I pointed out to my mechanic where the induction air duct is clamped to the output of the turbo compressor. And I said, well, if you've got a leak, oil leaking there at the clamp, that means that there has to be oil coming out of the turbo compressor, and that's where the oil consumption is coming from. There's oil getting into the turbocharger, it's being blown into the cylinders, getting burned in combustion, coming out the exhaust, and leaving a dark oily residue on the exhaust system. So I said, I think we just diagnosed your problem, and your problem doesn't have anything to do with the cylinders, and spending $14,000 on a top overhaul will not cure the problem. And so it turned out that the solution to Ted's problem was cured by overhauling the turbocharger, which was a $1,400 expense, instead of spending $14,000 to do a top overhaul on the engine, and then discovering after spending the $14,000 that the oil consumption hadn't improved. Now, let's just suppose, for the sake of argument, that instead of the scenario that I just described to you, which was what actually happened with Ted, supposing Ted had said that he was seeing a lot more oil on the belly than usual, that would indicate that that there's excessive crankcase pressure that's blowing oil out the breather. And most of the time, that means that there's excessive blow-by past the compression rings in one or more cylinders. Typically, not all of the cylinders. It'd be extremely unlikely for all of the cylinders to suddenly go bad, but probably one or two of the cylinders would have a problem. It isn't always caused by cylinders, although it mostly is. It could be something as simple as an oil filler cap gasket that wasn't sealing right. So when the airplane is flying and the engine compartment up above the engine gets pressurized with ram air because we're flying, some of that air is leaking in through the bad oil filler cap gasket and pressurizing the crankcase. Anything that pressurizes the crankcase will force oil out the breather. Most of the time it's one or maybe a couple of worn cylinders, but it can be something else that's a whole lot cheaper to fix. So we don't want to jump to any conclusions. And we almost never want to do a top overhaul because when we have this problem, it typically is confined to one or maybe two cylinders. It almost never is the case that all of the cylinders go bad at once. So the idea of doing a top overhaul is gross overkill, and it's very expensive. It also is very risky. Unfortunately, a lot of engines come apart catastrophically after a top overhaul. And I've unfortunately had to serve as an expert witness on a number of aircraft crash cases where airplanes fell out of the sky and people died as a result of a top overhaul that wasn't done correctly. So I don't like to see top overhauls done, both because they're overkill and they're wasting a lot of money, and also because they're risky. It's pretty much open heart surgery for an engine. It's very invasive, and there are a lot of ways to screw it up, and the consequences of having it screwed up are often pretty nasty. So if we see oil on the belly and we think that the problem is crankcase pressurization, the way we verify that before we just jump to conclusions and start throwing money at the problem is to actually measure the crankcase pressure. And the way we do that is to get an old oil filler cap and drill a hole in it and hook a hose to it. And on the other end of the hose, we connect an old altimeter that we use as a very sensitive pressure gauge. A Continental Service Bulletin M89-9, a very old service bulletin entitled Excessive Crankcase Pressure, gives the procedure for doing this on Continental engines, but the procedure works just fine on Lycoming engines as well. The idea is to hook a tube to measure crankcase pressure directly, and depending on the engine, the oil filler cap is usually a convenient place to do that, although there are other possibilities. We put an altimeter at the other end, we go out and do a full power run-up, and we see how much crankcase pressure there is. The Continental Service Bulletin gives some guidance as to how much crankcase pressure is excessive. And for big bore engines with 6 cylinders on them, it typically says anything over 90 miles an hour on the altimeter is excessive. And on smaller engines, it says about 45 miles an hour on the altimeter is excessive. But it gives us an ability to directly measure the crankcase pressure. If we see excessive crankcase pressure during this test, we know for sure that the crankcase pressure is coming from one or more cylinders. And we can also confirm that because almost always when we have a cylinder-related problem, the oil starts turning dark very rapidly after each oil change, much more rapidly than normal. Again, indicating that there's excessive blow-by getting into the crankcase.
Hey, Mike, can I just break in for just 1 second there?
Sure, you bet.
I have a few people commenting. We're wondering about the, you said on your altimeter, and you would check for the miles per hour your altimeter would be indicating. So, do you mean airspeed indicator? We hook the
Oh, did I say altimeter? I'm sorry. It's an old airspeed indicator that we use as a pressure gauge. That's absolutely correct. If I said altimeter, I was absolutely misspeaking.
Okay, airspeed indicator is what that hook should be hooked up to.
Yeah, did I have it wrong on the slide, or did I just say it wrong?
Go back.
Well, that's okay.
I think your slide might say altimeter.
Okay, then I screwed the slide up, and I apologize. But whoever commented on that, they're absolutely correct. It's an old altimeter that we're using as a pressure gauge.
Okay, thanks for clarification.
Pressure. Sure, absolutely. Sorry about that, guys. So if we verified that there's excessive crankcase pressure, we know that there's one or more cylinders that's causing it. And then we have to figure out which cylinder it is, and that can almost always be determined by means of a Boroscope inspection. If we see excessive oil puddling in a cylinder, then most likely that's the culprit, and we can usually see that pretty clearly by sticking a Boroscope in there. But a top overhaul is almost never appropriate, and as I said, I don't like to see them done, both because they're expensive and because they're quite risky. Typically, elevated oil consumption caused by crankcase pressurization, especially if it's something that happened quickly, where the engine was not using a whole lot of oil and all of a sudden it started using a lot of oil, which is kind of what Ted reported. It's almost always going to be confined to one or two cylinders, and we need to use Boroscope to figure out which cylinder is the culprit, and not use the shotgun approach of changing them all. When you stick a Boroscope in the cylinder, one thing we look for is oil puddling. Another thing we look for is the condition of the cylinder walls. Here are a couple of Boroscope photographs just to sort of give an example of what we see when we look at the cylinder walls. A relatively new cylinder will have a very distinctive crosshatch hone pattern on it. And if you see the crosshatch, you know that there's almost no wear on the cylinder walls. As the cylinder ages, it's normal for the crosshatch pattern gradually to start fading out, and for a certain amount of vertical scoring to occur, light vertical scoring. In a heavily worn cylinder, you won't see any crosshatch, and there'll be areas of shiny metal where there's literally no signs of any hone pattern at all. And so if we see cylinders like that, they're likely to be the culprit. Now, just because you have a heavily worn cylinder doesn't mean that you're necessarily going to have high oil consumption. But if you do have high oil consumption, and we've used the tools that we talked about so far to verify that it's cylinder related, and we're trying to figure out which cylinder needs to be changed, this is a good way to determine which cylinder it is, by looking at the condition of the cylinder walls and also looking for the presence of oil puddling in the cylinder. Whoop. Now, if we do this run-up and our altimeter does not, I said it again, our airspeed indicator, what's the matter with me, does not show excessive crankcase pressure, then we know that it's not the cylinders that are pressurizing the crankcase. It has to be something else that is pressurizing the crankcase when there's 200-mile-an-hour air blowing into the engine compartment, but isn't pressurizing the crankcase on the ground where there's very little airflow into the engine compartment. So then we would suspect something like an oil filler cap, maybe a leaking for an oil seal, other ways that ram air in flight could get into the crankcase and pressurize it and push oil out the breather, but that doesn't happen on the ground when we don't have a lot of airflow in the engine compartment. The other possibility, if we're getting a lot of oil on the belly, but we're not seeing excessive crankcase pressure during a full power run-up, is that it is not that something is pressurizing the crankcase and blowing stuff out the breather, but that it's something that's sucking oil out the breather. And typically that is a breather tube outlet that has not been positioned correctly, and is in a low pressure area in flight and is actually causing suction that's pulling oil mist out of the breather. I've seen this a lot on Cessnas where the positioning of the breather tube outlet is very, very critical, and sometimes all it takes is repositioning that a little bit. Again, if there was any maintenance work done that would have disturbed the positioning of the breather tube, then that would be a suspect that we'd want to look at. The least likely cause of high oil consumption is a leak in the engine, and it's least likely simply because it would have to be a really big leak to cause noticeable increased oil consumption, and a really big leak is pretty obvious, like in this picture. But if we have a leak in the engine compartment, it's always worth finding and fixing those leaks, because we want to make sure that some small inconsequential oil leak doesn't cover up something important like a crankcase crack. So we would really like the engine and the engine compartment to be nice and dry and oil-free. And even if we have some small oil leaks, they're typically worth fixing. Now, finding the source of an oil leak is sometimes challenging because it's amazing how much a little bit of oil can cover when it's being blown around with 200-mile-an-hour air. And so the key to finding oil leaks is to spray down the engine with solvent until it's scrupulously clean and there's not a trace of oil anywhere, and then do a run-up on the ground and not fly it so that the oil spreads around, and see if you can identify what the source of the oil leak is. Sometimes, if it's a particularly hard thing to identify, spraying some white aerosol powder like dye-penetrant developer or even jockage spray on a suspected area, and then doing a run-up will be helpful in identifying where the oil leak is coming from. But again, an oil leak is a pretty unusual reason for high oil consumption, because in order for the oil consumption to be significant and noticeable, it would have to be a very big leak. So at any rate, the bottom line is that when faced with high oil consumption, resist the temptation to throw a lot of money at the problem, and instead take some time to work through the diagnosis and pinpoint exactly what's causing the high oil consumption before you pull the trigger on actually trying to fix the problem. And Tim, that's all I have in terms of prepared stuff. Sorry about the altimeter versus airspeed indicator mix-up. For some reason, I'm having an altimeter thing burned into my brain tonight, and didn't mean to say that. And I'm glad somebody caught the error.
Oh, hey, no problem. Yeah, I'm glad we got it clarified for everybody else.
I think it's old timers disease kicking in.
Oh, I doubt that. Hey, that's a good lead-in. We had a couple questions here. People wanted to follow up a little bit about that. So Douglas is wondering, what is normal crankcase pressure?
Well, again, it sort of depends on the size of the engine. The Continental Service Bulletin indicates that for small four-cylinder engines, a reading on the airspeed indicator, did I say that right?
You got it.
Up to 45 miles an hour is normal, and for big six-cylinder engines, up to 90 miles an hour is considered normal. And for Lycoming doesn't give any guidance on that. I don't believe that they have a service bullet on crankcase pressurization, but you could sort of extrapolate that same stuff to Lycoming engines.
Okay, and Doug is wondering, do you block the crankcase vent during the pressure test?
Oh no, no, not at all. If you did that, the crankcase pressure would go through the roof. No, this is running the engine up in its normal configuration, but with a tube hooked to measure the crankcase pressure, typically using a tricked out oil cap, although there are other places you can hook the tube as well. But no, you certainly would not block the breather.
Okay. Richard just asks, is a Continental or Lycoming engine more prone to higher oil consumption?
Well, I don't know a scientific answer to that. I don't know if anybody really has data. In my experience, Continentals tend to burn a little bit more oil than Lycomings. But then most of the Continental engines I deal with are big ones, 550s, 520s, and a lot of them are turbocharged, and all of those things would cause the engine to burn more oil. And obviously, the smaller the engine, the less oil it's likely to burn. So, you know, O360s, no 320 likes would tend to burn a whole lot less oil, just because they're smaller. If you measure the circumference of all of the piston to cylinder interfaces in the engine, the oil consumption tends to vary with that number. And the bigger the bore and the more cylinders you have, the more oil, the more blow by you're going to have, and the more oil is going to escape the engine.
And Richard's wondering, will having an oil filter installed at the time your engine is new help to keep oil consumption down?
Probably not. There are really good reasons to install an oil filter. And we're going to be talking about that in an upcoming webinar on the subject of bearings and so on. But I don't think having the difference between having an oil filter and an oil screen would affect oil consumption significantly. It does affect a lot of other things, but I don't think it would affect oil consumption measurably.
Okay. And H asks, is there a difference between the oils? And I assume maybe he means different types of oil. Would it lead to greater consumption or not?
Well, there is a significant difference between oils, and I have a webinar in the EAA archive all about that, and it's entitled All About Oil, that you might want to review. Also, I think I wrote a two-part article for Sport Aviation on that subject that's in the sportaviationonline.org archive. But generally speaking, thick single-weight oils will have a little bit less oil consumption than multigrade oils will. It's not a huge difference, though.
Okay. Donald wonders, how many hours on a major overhauled Continental 0470 with chrome cylinders would it be till oil consumption should stabilize? And what consumption might be considered normal?
Well, if we're talking about traditional channel chrome cylinders, chrome-plated cylinders with channels on them, as opposed to something like Chrome, which I don't think they make anymore, or the ECI nickel cylinders. But if we're talking about the traditional old chrome channel chrome process, those cylinders are actually very, very good, and they last for a very long time. But they take a long time to break in. a lot longer than nitride steel cylinders, or especially something like ECI nickel. And even when they're fully broken in, the oil consumption tends to be quite a lot higher than other types of cylinders. So in an 0470 that has channel chrome cylinders, I would expect that the break-in could take as much as 50 hours before the oil stabilizes, and it typically will stabilize at something like a quart in 5 hours, maybe a quart in 6 hours if you're really lucky. But you aren't going to get real low oil consumption like a quart in 10 or better with channel chrome cylinders. It's just kind of the nature of the beast. Now that's not a bad thing, and I don't have any problem with channel chrome cylinders. It's just that you need to accept that one of the characteristics of channel chrome cylinders is that they use more oil. They blow by more oil than other types of cylinders. On the other hand, they wear like iron. The chrome is very, very hard, and the cylinders last a long time. So it's a good thing, but you do have to add more makeup oil when you have chrome cylinders than you typically do with other kinds of cylinders.
Jim's wondering, would someone have seen blue smoke from the exhaust in Ted's example case that you gave?
Very possibly during startup and shutdown. That might well have been the case. He didn't mention that anybody had noticed that, but on the other hand, that requires somebody, standing outside of the airplane and looking while the engine is started, and that's probably an unlikely event. But yes, I think there would probably have been a good chance that you'd see some smoke coming out of the exhaust.
Okay, Dave's wondering about CamGuard and what effect using CamGuard might have on oil consumption.
I don't think CamGuard would have any particular effect on oil consumption. The main claim to fame of CamGuard, and I am a big fan of it, and I use it in my airplane, is as an anti-corrosion additive, and the main benefit of using it is preventing cam and lifter spalling. It does also have the effect of preventing some corrosion pitting if you have steel cylinders and you don't fly the airplane real regularly. And I guess in the long run, corrosion pitting would have an effect on oil consumption, because it would allow excess blow by at mid-stroke when the engine is running. So it might have some small effect on oil consumption for airplanes that fly very irregularly. For airplanes that fly, on a regular basis once a week or so, the effect would probably not be noticeable with respect to oil consumption.
Brock wonders, what is the recommended procedure and solvent for use for a ring wash?
Well, we've used all sorts of stuff. The guy who has the most experience with the ring wash procedure is the guy who invented CamGuard, and he has a snake oil mix that I have stashed away somewhere. I don't have it committed to memory, but it's largely a Stoddard solvent or Varsol, kind of the standard solvent that people use in parts cleaners, with a little bit of MEK added to it, just for a little bit of more solvent effect. I've done the ring wash using avgas, although I can't recommend that because of the fire hazard, but I have done it with just using avgas as the solvent. But a started solvent is a lot less flammable, so it's a lot safer to use. We don't want to use anything super aggressive, like filling the combustion chamber with MEK or acetone, simply because we don't want something strong enough that it can start softening O-rings and stuff. We've had some people use real aggressive solvents, and it's messed up the O-rings in their oil quick drains, and they've had to change it. So we don't want something super aggressive in there because we don't want any collateral damage.
Okay, Carl wonders, why does the oil turn dark with excess cylinder pressure?
Simply because the excess cylinder pressure is being caused by excess blow-by past the compression rings, and so the stuff that's pressurizing the combustion chamber is not like nice clean air or anything. It's byproducts of combustion, basically the same stuff that comes out the exhaust pipe, but it's going into the crankcase, getting past the compression rings, and so all of the unburned byproducts of combustion are mixing with the oil and turning it dark. I mean, that's why oil turns dark anyway. It's just that if there's excessive blow-by, then the oil's going to turn dark a lot faster.
Jason wonders, what about pitting in the cylinder walls from rust? Would that cause the oil to get dark quickly?
Yes, if you have a lot of corrosion pitting, which typically happens at mid-stroke, it can cause excessive blow-by and all the symptoms that we were talking about, elevated oil consumption and oil that turns dark. And one thing that I want to point out is that if you do have corrosion pitting, it will almost never show up on a compression test. You can have a compression test that measures 77/80, because the compression test is only measuring the ring seal against the cylinder walls up at the very top of the stroke, up at top dead center. And if you have corrosion pitting, it's almost always at mid-stroke, and it won't show up on a compression test. But where it will be very obvious is when you stick a borescope in the cylinder and look at the cylinder walls. Then it'd be quite obvious that you've got corrosion pitting. That's why I'm sort of a big fan of borescope inspections and not a particularly big fan of compression tests. The borescope sees a lot more and is much more revealing of what's really going on.
Lewis wonders, how do you know whether your breather tube is correctly positioned?
Well, I don't know what he's flying, but on a certificated aircraft there should be a drawing that shows exactly how it should be positioned. And this is something that's that the manufacturer does a lot of experimentation with during certification to get it to just the right position.
How about on an experimental, where we as builders determine that? What would be some advice for us to locate it?
Well, basically on an experimental, you'd have to do the same thing that a manufacturer does during certification, which is try a variety of different positions and see which one results in the lowest crankcase pressure.
Okay, just a comment here from Don. He said, I had an oil usage problem with excessive crankcase pressure that turned out to be a bad crankshaft seal, allowing
Yes.
air to enter at the front.
Right. That's one of the, I think I actually mentioned that during the prepared remarks, that's one of the places that ram air can get into the crankcases through a leaking crankshaft seal up at the nose of the case. Now, usually when you have a crankshaft seal that's worn that badly, it'll also start leaking oil, and you'll notice it that way, and you'll see like an oil mist on the windshield, but not always. But the two things that are frequent culprits when we have elevated crankcase pressure, but it's not coming from the cylinders and it's not causing the oil to get dark, would be the front crankcase, front crankshaft seal, and the oil filler cap seal. And on engines where the dipstick is separate from the oil filler cap, like on 0470, for example, the O-ring that seals up the dipstick would also be a possible culprit. Anything in a high pressure area of the engine compartment that goes into the crankcase, has to have an airtight seal on it. Otherwise, the ram air will pressurize the crankcase and blow oil out the breather.
Okay, Craig wonders, if the problem is oil being sucked out the breather tube, what's the solution to correct it?
It's to move the breather tube to a better position. Also, another thing is some of the breather tubes have a discharge end that's cut off at a 45-degree angle, and it's important that that be angled in the correct position, so that it's not creating a lot of suction.
Got it. Okay, Bradley wonders, is there any situation whatsoever that you would recommend a top overhaul?
Well, I'm trying to think of the last time I did. I think the last time I did, it was a situation where Continental was willing to pay for all of the cylinders and all of the work under a warranty, and we flew the airplane down to Continental Service Center in Fairhope, Alabama, to make sure that the job was done exactly right. But it's pretty rare. I normally advise strongly against doing a massive multiple cylinder changes, just because it's so easy to screw it up. And if you absolutely have to do it, it really needs to be, you really need to fly the plane to an engine expert to do it, and not let local mechanics in the field do it. It's just too risky a procedure.
Okay, William wonders, where can I get a copy of M89-9?
Well, that's a good question. I think that service bulletin is so old that it's not online on the Continental website where most of the service bulletins are. But if he sends me an email, I think I have a paper copy of it, and if I do, I'll put it through my scanner and send him a PDF of it scanned. I can't promise I have it, but I think I do in paper.
Awesome.
I'll probably regret saying that, because I'm now going to get 400 requests or something. But
there you go. Well, you could maybe just post it to your website. Okay, so
well, I'll go look for it for sure.
Eugene has a question. If you would make some comments on a break-in period for new or overhauled engines.
On a break-in period, how long it takes to break in the cylinders?
Yeah.
Well, it depends on what kind of cylinders they are. If they're the traditional nitrided steel cylinders, like Continental or Lycoming new cylinders, if you do the break-in procedure correctly, then normally it's all over within 10 or 15 hours. If the cylinders are channel chrome, like we talked about, it might take up to 50 hours. If the cylinders are ECI ceramic impregnated nickel cylinders, they'll probably be broken in 2 hours. So it depends a little bit about with what kind of cylinders it is. It also depends a lot about the actual procedure that's used for break-in, and I probably ought to do a webinar or write an article or both on that subject, because I do get a lot of questions about break-in.
Cool. Matt says, my A36 IO550, I put in 10 quarts. It seems to blow that out to 8.5 quarts, then stabilizes. Is that normal?
Well, I'd have to look up what the sump capacity of his IO550 engine is. I don't know whether it's 10 or 12. As a general rule, engines are typically not real happy when you fill the oil up past about the 2/3 of full capacity point, and they tend to blow the excess out the breather, particularly when the airplane is in a nose-up attitude, like on takeoff and climb. And so we generally recommend running the oil at about 2/3 and not letting it get much higher than about 2/3 of the maximum sump capacity. So, for example, on my engines, on my Cessna 310 that have 12 quart sumps, I normally don't let the oil get much above about 8. We manage a whole lot of Cirruses that have only 8 quart sumps, and We don't let the oil get above 6 because anything above 6 will promptly exit the engine. All of these engines, as a matter of certification, are required to operate properly with the sump at half capacity, and that's a certification regulation that has to be demonstrated during certification. That in all normal flight attitudes, nose up, nose down level, that the engine will run just fine with the oil at half the sump capacity. And many engines, depending on the shape of the oil sump and so on, are happy with a lot less oil than half capacity. In particular, most small Lycomings will run just fine down to about 2 quarts. I'm not suggesting that you run them down that low, just that you shouldn't be nervous about not filling the oil up to the top. It's generally not a good idea to fill it up to the top. In the Cirruses that we maintain with the 8-quart sump that doesn't like to be filled more than 6, the engine is happy down to 3.5 quarts. And by the way, whatever engine you happen to have, you can go to the type certificate data sheet for that engine that's on the FAA.gov website, and it will tell you how much of the oil is usable. And if you take the total consumption and you subtract the usable consumption, you get the unusable oil, which is the level at which the engine starts getting real unhappy. And for any engine, you can just go and look that up on the type certificate data sheet. But on the IO550N and the Cirruses, that number is 3.5 quarts. So we typically tell our owners to not fill that 8-quart sump any higher than 6, and to add a quart when it gets down to 5 or 4.5. We don't want it to get close to 3.5 because that's when things start going bad.
Douglas wonders, what do you think of breather vent separators?
Air oil separators, I hate them. I generally advise my managed maintenance clients that if they have installed an aftermarket air oil separator, they remove it. I hate them for 2 reasons, and this could be a whole night's discussion, so I won't let that happen. The first reason is that an air oil separator is not really an air oil separator. It's a liquid gas separator. It can't tell the difference between oil, water, sulfuric acid, any liquid that comes to it, it tries to return back to the engine. And one of the main purposes of having a breather on these engines is so that the engines can expel all this nasty stuff. And if we have a device that inserted in the breather that routes that stuff back into the engine and prevents it from leaving the engine, that's not a good thing. The best description of this problem that I've ever heard came from my friend John Schwanner, who is now retired but was one of the best engine guys that I've ever met. And he had this wonderful thing on his website. I think it's probably still there. Tim, if this offends anybody, you can edit it out. But he basically said, putting an air oil separator on an engine is like running a tube from your anus to your mouth. And I think that's a very, very graphic description of exactly what the problem with those things is. The second reason I don't like them is because if the engine does have a crankcase pressurization problem, and we have an air oil separator in there that's not letting that oil go out all over the belly like God intended it to, we're putting a Band-Aid on the engine and concealing a symptom that we really want to be able to see. So anyway you cut it, I really don't like those things. And as I said, when we take an airplane under our managed maintenance program and find out that it has an aftermarket air oil separator, I try my best to convince the owner that he ought to have it removed and restore the breathers back to the way it was originally designed. Now there are a few engines, typically turbocharged, that have a small air oil separator installed by the factory. Those you basically have to leave alone because they're required by certification. But we see a lot of airplanes that have had aftermarket separators, put on M20s and Airwolves and stuff, and we always recommend our clients have them removed.
Okay, Rusty's wondering if you could please speak to crank seal integrity as it relates to crankcase pressure.
Well, I'm not sure what more to say about that than we've already said, but if you do have a leaky front crank shaft seal, then when the airplane's in flight, air can get past that crankshaft seal into the crankcase, pressurize the crankcase, and cause excessive discharge out the breather.
Gotcha.
Not sure. I'm not sure what to say more about it. It's pretty much that simple.
Okay. Paul wonders, don't most manufacturers have oil consumption formulas for most engines?
Well, I don't know if most of them have formulas. I know Continental does for all of its engines, and it's a formula that's sort of a little complicated because you basically stick horsepower in, and you get oil consumption numbers out in, you know, something like liters per hour or something, and we all need to convert it into hours per quart, which is the way most people think about this thing. But certainly with Continental engines, there is a formula. That formula is on the engine type certificate data sheet, so it's easy to look up. And if you work the numbers, you know, on a 300 horsepower Continental engine, kind of like what Ted has, the numbers come out that the maximum acceptable oil consumption comes out to be roughly a quart an hour. It would be less than that on a small engine, of course, because it's
Gotcha.
a function of horsepower.
Okay. James asks, if you have a good air oil separator trapping oil from the crankcase exhaust and you're still getting oil on the belly, doesn't this almost have to be an engine oil leak?
No, it's pretty easy to overrun the air oil separator, and a lot of air oil separators don't work. I mean, one of the ones we see installed a lot is something called the M20 separator. Comes out of an outfit in Florida, and it just flat ass doesn't work. The best air oil separator is the Airwolf, but it has to be installed exactly correctly, and the installation is very, very tricky and very complicated and sensitive. And if it's not installed exactly right, it will discharge lots of stuff out the breather. So just because you have an air oil separator doesn't mean that it's doing a good job of separating.
Dan asks,
it's just best to get rid of those things.
Okay, Dan asks, are UV dyes ever put into the crankcase to help determine a leak source? Is this allowed by the engine manufacturer and the FAA?
I've never heard of anybody doing that. Obviously, we use that for like air conditioning systems and so on, but I've never heard of anybody adding a fluorescent dye to the oil to determine the source of an oil leak. I have never seen any manufacturer's guidance suggesting that. I don't necessarily think it's a bad idea, and frankly, I don't think you'd be violating any regulations by doing it. Might be fun to try, but I'm not aware that anybody recommends doing it for piston aircraft engines. Now, I have to preface that by saying almost all of my engine experiences with Lycomings and Continentals, and not with Gabarus and and Rotaxes and stuff like that. So I can't speak for all engine manufacturers, but certainly Continental and Lycoming don't have any recommendation for doing that. I don't think you'd be breaking any rules by trying it, though.
Peter says at 2200 RPM she uses oil. At 2500 RPM she doesn't. Is this because the cylinder pressures at the higher speed are making the rings work better?
It could very well be. While you were reading the question, the gears were turning in my head, and that's exactly the explanation I came up with. So I think it's very possible that that is correct. It is combustion chamber pressure that is responsible for forcing the rings against the cylinder walls. And the higher the pressure, the more tightly the rings are sealed. So that is a definite possibility.
Brian asks, I have a Continental 0300D on my Skyhawk. I have leaks at the rubber pushrod boots. Any thoughts on how to fix these?
Yeah, it's, almost every engine develops those leaks after a while, and the boots have to be replaced. Now I have to confess I've not worked on 0200s and 0300s, so I don't know the exact procedure. We replace the pushrod housing seals on Continental 360s, 470s, 520s, 550s all the time. It's a very, very common source of leaks, and and we change them all the time. I just don't really have any time working on 0200 and 0300 engines. I know they use a different method of sealing those things, and so I don't know the exact procedure for doing it. I'd have to look it up in the book.
Okay, Ray says, what amount of oil, if any, is acceptable on the belly? My high time Lycoming puts out some, but so does my neighbor's very low time engine.
That's absolutely normal. I mean, they put a breather in these engines because you have to discharge excessive pressure. You get pressure because the rings don't seal perfectly against the cylinders, and they never do in these engines. Since the contents of the crankcase is not just air, it's a very, very dense oil mist when the engine is running. For air to come out the breather, it's going to carry some oil with it, and that's just normal. It's when it becomes abnormal. I heard one mechanic, some customers complaining about oil on the belly, and the mechanic said, and he said, how much is too much? And the mechanic said, if it's reaching the tip of the tail cone, it's too much, which I thought was pretty funny. But no, it's absolutely normal to have some discharge out the breather. That's just the way things work.
Question here
from Matt. For metal airplanes, I always tell the owners, hey, it's a good corrosion preventative. For plastic airplanes, that argument doesn't work, so I have to come up with something else.
Right. Question here from Matthew. He's just wondering, mineral oil for break-in, is that recommended?
Well, the manufacturers recommend that. It's sort of an old tradition dating back to World War II. To be honest with you, I have never seen any evidence that an AD oil like Aeroshell W100 doesn't do every bit as good a job at break-in as Aeroshell 100 without the W, which doesn't have the AD additives in it. The two things you want to avoid when you're breaking in an engine, you don't want to use an oil with any synthetics in it. So you don't want to use Aeroshell 15W50. You don't want to use Exxon Elite. You want an oil that's made totally out of dead dinosaurs. And the other thing is you don't want to use any anti-scuff additives. You don't want to put CamGuard in the engine. You don't want to put Lycoming LW16704 or whatever the name of that snake oil is in the engine until the break-in is complete, because they're anti-scuff additives, and the whole idea of break-in is to get some scuffing to happen. But I've actually never seen any evidence that an AD oil like Aeroshell W100 isn't every bit as good for break-in as a traditional straight mineral oil like Aeroshell 100 in the red can without the W in front of it.
Okay. Michael wonders if he should use CamGuard while braking in an engine.
Absolutely not. Again, CamGuard has a pretty effective anti-scuff additive in it, and we don't want anti-scuff additives in during break-in. We don't want anything. I mean, we're looking to achieve metal-to-metal contact between the rings and the cylinder walls, and we don't want to put anything in there that defeats that. Once the break-in is complete, then we definitely want to put something in there to defeat it, but during break-in we don't.
Richard wonders, what about Marvel Mystery Oil for a ring wash?
Well, I wouldn't recommend using Marvel Mystery Oil only because to do a ring wash on an engine takes gallons of the stuff, and Marvel Mystery Oil is a very expensive way to go. Also, I don't think Marvel Mystery Oil really has quite enough solvent effect, and it's red, so if you spill any, it's going to make stains all over everything. So I wouldn't particularly recommend using Marvel Mystery Oil for ring wash. Use Varsol or Stoddard solvent, something really cheap that you buy in 5-gallon pails, and then put a little more aggressive solvent mixed in with it, like MEK or acetone or something. But don't put enough concentration in there to start dissolving things.
Okay. Walt wonders, how would you test crankcase pressure with an E-series engine with a dry sump, such as a BE-35?
He just exceeded my pay grade with that question. I've never worked on an E-series engine. Okay. I take it that it has an oil tank like an O200 or 300 from his comments, but I don't know anything about those engines, so I really can't comment.
Okay. Let's see here.
There's a world's expert on E-series engines named Lou. I'm trying to think of his last name. It'll come to me. But if a question ever comes up about an E-series engine, we always take it to Lou. I need to find it. I need to figure out what his last name is, but he is the world's E-series engine guru.
Okay. Long question here from Patrick. He says he has a Lycoming 0360. He's flown over 2,600 hours, no major overhaul in the last 35 years. It has always only used 2 quarts of Phillips cross country in every 25 hours between oil changes. Put in 7, work it down to 5 in 25 hours, then change the oil. 2 years ago, and about 52 hours ago, I started putting in cam guard, and since then the engine has really started going through the oil. It turns black very quickly after the oil change, not like before, and now seems to be burning through a quart every 2 hours. What are your thoughts on what's happening?
Well, first of all, I don't think it's the cam guard that's causing it, although, I mean, we often do see black-looking oil on the first or second oil change after somebody starts using cam guard, simply because cam guard tends to wash a lot of junk out of the piston ring pack, and it gets into the oil and during the first or second oil change. But I can't think of any possible reason how cam guard could possibly affect oil consumption. So I suspect that the increase in oil consumption is a coincidence, and that it's not really caused by the cam guard. It's caused by something else. And we would need to go through the same sort of diagnostic tree that I talked about to figure out exactly what's going on.
Okay. A couple people commented here. Kent said that the E225 expert is Lou Gage.
Yeah, exactly.
Lou Gage.
LEW.
LEW, yep. And they also recommend American Bonanza Society. Okay, Brock is wondering, how would you go about performing that ring wash? Drain the sump after forcing solvent past the rings? Ground run the engine with the solvent in the sump?
Oh God, no. Jesus. No. Again, I've got a write-up from Ed Collin that we use as our Bible for how to do this. And again, I'll do something I regret, but if somebody wants to do a ring wash, drop me an email and I'll find a copy of that thing and send it to you. No, basically you drain the oil, you leave the oil drain open with a bucket under it, and then one cylinder at a time you go through and perform the ring wash procedure. You remove the top spark plug, put the piston at bottom dead center, fill the combustion chamber through the top spark plug hole with a funnel with the solvent to the brim, put the top spark plug back in, and then pull the prop through slowly and force that solvent through the ring pack. And you can, after you've done it a few times, you can sort of feel how much resistance there is, and sometimes you want to repeat the procedure 2 or 3 times until you feel that you've washed all the crap out of the ring grooves, and the solvent moves past the rings nice and smoothly without a lot of resistance. And then you go on to the next cylinder and lather, rinse, repeat. And after you're done with the whole thing, then we wash down the inside of the cylinders with oil that we squirt in through the spark plug holes, because at the end of the ring wash, the cylinder walls are just completely stripped of oil, and when you turn the prop, you hear the rings squeaking against the cylinder walls almost like nails on a blackboard. So we spray oil in there to restore the oil film on the cylinder walls before we start the engine. Put all the spark plugs back, fill the sump with fresh oil, change the oil filter, and then go out and run the engine.
Got it. Okay. Hey, Mark sent us all a link here to what he said is M89-9. He says he found
it.
Cool. So it's
cool.
at www.aircoop.info/ a bunch more. And
it sounds like if you Google it, you'll find it. That's great.
Yes, www.aircoop.info. And if I did my job correctly here, I think that I sent it to everybody.
Oh.
In response to a question, so everybody might have that in their little.
Oh yeah, I see it in the message area. Very good.
Yep. So that's the link right there. If you want to maybe copy and paste it onto your desktop or into a different web browser or something like that. Okay, so Rick is wondering, how do you feel about remote oil filter kits, such as the Airwolf remote oil filter kit?
I feel fine about them. There are pros and cons of putting in a remote oil filter. The pro is that usually you can mount it in a place that makes it very easy to change the filter with a minimum of mess. The con is that you're adding a couple of hoses, which are potential failure points. So you just have to make sure that they're really good hoses and they're well secured and they're not capable of rubbing up against anything or whatever. But generally, I feel fine about the remote mounted filter, and particularly on engines where an engine mounted filter is really hard to get at and really hard to remove without making a big mess. A remote mounted filter mounted in a convenient place on the firewall is usually a very good idea.
Gotcha. Okay, so we've had a number of people ask about the diagnostic camera, the Boroscope, and if you got a recommendation for such.
Yes, I do. A really excellent Boroscope that is what I'm recommending to people nowadays is the Snap-on BK8000. Bravo Kilo 8000. It sells for about $1,000. Sorry about that. I've not found any Boroscope that sells for significantly less that provides adequate image quality and adequate lighting. A BK8000 would be a perfect thing for an EAA chapter to buy for the benefit of its members, because I mean, normally, as an aircraft owner, you only really need access to a Boroscope a few days a year, and this would be just a perfect thing for an EAA chapter for everybody to go in on, and then have it available for all of the members. The earlier Snap-on Boroscopes, the BK5500 and BK6000, are terrible. Don't even think about them. Most of the low-cost Boroscopes, like the stuff that you can find at Harbor Freight, are terrible. But the BK8000 is really, really excellent, and it has every capability you can think of. It's got a dual head that can be switched between having a 0-degree viewing angle and a 90-degree viewing angle. A 90-degree viewing angle is perfect for looking at valves and stuff, and the 0-degree viewing angle is very good for looking at piston crowns and parts of the cylinder walls. It captures movies. It captures JPEG stills. It makes it very, very easy to capture images and then transfer them to your laptop or email them to somebody. It's just a great instrument. And again, it costs about $1,000. You can get it from any Snap-on driver, or you can get it from the snapon.com website.
Okay. As you were talking, we had a few people chime in, and Doug said he found a inexpensive dental digital camera. He said it works great for him and cost about $100. Mark said that he found a medical surplus instrument that he thought may have been used in colonoscopies. So
there's a thriving business in medical scopes on eBay, and some of the medical scopes are really, really excellent for this kind of work. A problem with the medical scopes is, first of all, most of them have a 0-degree viewing angle, which doesn't work at all when you're trying to image exhaust valves and stuff. You have to have a 90-degree angle, which basically means having a 45-degree prism or something at the end of the probe. And most medical scopes don't have that. Also, when you're buying a medical scope, normally the light source is separate, and so you need to be absolutely sure of what you're buying. But some of the medical scopes are really terrific, and there's a thriving business with them on eBay. The dental intraoral cameras, the cheap ones. I actually use a dental intraoral camera in my hangar for doing some boroscopy, but it's a very expensive one, and it has a 50-watt light source. Most of the $100 dental intraoral cameras that come from Japan have inadequate light source. You can usually image valves okay with them, but you usually can't do a real good job of getting cylinder walls and stuff because the light just isn't bright enough. Some people are using them successfully, but like I said, the best scope that I know of right now is that Snap-on unit. It's extremely good and very, very versatile.
Great. Lewis says, if there is excess blow-by past the piston rings, can this result in high engine oil temps? I have a chrome cylinders on my Lycoming 0235.
It can. Excessive blow-by past the rings will result in an additional heat load on the oil. Now, whether that results in high oil temps or not depends on how good an oil cooler you've got. If you're not, the oil cooler is thermostatically controlled, and as long as you're not putting more of a heat load into the oil than the oil cooler can get rid of, it will hold that oil temperature thermostatically controlled at whatever the set point of the vernitherm is. But if there's enough excessive heat getting into the engine because of excessive blow-by that it exceeds the capacity of the oil cooler, and the vernitherm is completely closed and putting all the oil through the cooler, and it still isn't capable of holding the oil temperature down, then you'll get excessive oil temperatures.
Okay, Ricky's wondering what's involved in replacing a crankcase seal.
A nose seal?
Mm-hmm.
It's not a big deal. It's usually about a 4-hour job, and the two biggest problems are, first of all, you got to pull the prop to do it, and the second issue is that you need to stretch the seal over the prop flange without damaging it. So normally you heat the thing up in hot water or something to make it real pliable, and then you work it over the flange. There are some other tricks involved in installing it and making sure that it seals correctly. But it's typically about a 4-hour job, and a lot of it is because you got to pull the prop and then you got to reinstall the prop, and so there's some overhead involved.
Gotcha. Amy says, how does having a plane that drools after flight from the breather tube fit into this discussion? If there's no oil on the belly, or said more generally, why do some planes with horizontally opposed engines drool from the breather more than others when parked?
Well, I'm sure it has a lot to do with the configuration of the breather. I mean, for example, on the TSIO 520s in my 310, the breather attaches right to the oil filler neck, kind of right where the oil filler cap attaches. And after I shut down the engines, if you pull the oil filler cap, it's just coated with water, with kind of dirty water, because the engine is full of steam. Massive quantities of water are generated by the cylinders during combustion, and so there's a lot of steam that gets into the engine, and it rises up to the high point, which on my engine is where the oil filler cap attaches, and that's exactly where the breather attaches. So so it would be easy to imagine that stuff dripping out the breather, depending on how the thing is configured. But I suspect that if you're seeing stuff dripping out the breather after you shut down, it's mostly water, and it's due to the phenomenon I'm just talking about.
Okay, looks like we got about 4 minutes here, so let's get a few more in. Let's see, sorry about that. Oh, just a couple comments. We got a couple people that did comment that they were able to download the, is it 89.9 from the Continental website also. So
oh, really?
it's there
oh,
on
really? I'm surprised
somewhere.
it's there just because it's so old.
Yep.
But that's good. Okay, good to know.
Okay, so Gustavo says,
So don't you guys be emailing me for a copy now. You can get it yourself.
You're off the hook. Yeah. So we had a couple people wondering if they can get a copy of the presentation also. Would you be willing to share your presentation with them if they contact you?
No, we don't do that. The only way to do the presentation is to stream it off of EAA.org.
Watch it, the video. We'll have the video made and posted tomorrow, so you can go there and download it from EAA.org/webinars. Gustavo wonders, can excessive pressure at crankcase destroy internal elements of the engine?
I've never heard of anything like that happening now. I mean, I can't see how the pressure could ever get high enough to do any damage unless the breather was actually obstructed. So
no, I guess
except like in some very aberrant case, I can't imagine that would ever be a problem.
You bring up an interesting thing about a breather being obstructed. Seems to me when I owned my Cessna, there was a little slot cut about 4 or 5 inches from the very bottom, like in the back, and it was
right. It's called a whistle hole,
and
it's generally found on most breathers, and the reason for that is to protect the engine in the event that you're flying in icing conditions and the breather discharge tube gets obstructed with ice. It provides another exit for the air coming out the breather.
Usually that's on the back side of the tube as well, isn't it?
Don't remember.
Yeah, I know mine was.
I think it's something like that is required by regulation so that the engine won't be compromised even if the end of the breather tube ices up.
Michael's just wondering, can you comment on the problems arising from broken rings and how to diagnose?
Well, broken rings don't happen all that often, but when they do, they're very easy to diagnose because they cause really pronounced, ugly-looking vertical scoring on the cylinder walls, and it's very obvious when you look into the cylinder under the Boroscope that you've got, you know, vertical scoring, really bad vertical scoring.
Gotcha. Let's see. A lot of people have individual questions. They chimed in about you know, their particular engine, and normally, you know, they put in 8 quarts and it goes down to 5, or they put in 10 quarts and it goes down to 8, and they're kind of wondering if that's normal. But I think you covered that fairly well. That most engines really like to run about, what did you say, about two-thirds of their capacity?
Of max
Is
capacity,
they would like to run?
Uh-huh.
Yeah.
That's a good rule of thumb in general.
So that should be pretty reassuring to all the people who kind of wrote in with a specific question about their plane. If it's okay that they lose that first quart or 2 quarts or 3 quarts right away.
It's actually better just not to put them in the first place.
It's cheaper, isn't it? Makes for less expensive oil changes.
And cleaner if it's winding up on the belly, which is where it usually winds up.
Right, right. Well, that's wonderful, Mike. We've bumped up against the end here of our time. Do you have any closing comments you'd like to make to the audience?
Well, just quickly to review a couple of the next 3 Wednesdays, first Wednesday of the month webinars. In April, we're going to be doing something on bearings, the plane bearings that are used for main bearings and rod bearings and so on in our engines. It's a pretty interesting subject. In May, the webinar is called Owner and Command, and it talks about owner's responsibility for managing maintenance and sort of the general mindset that I recommend owners have when they're dealing with the shops and mechanics. And then June has a very subtle title, How to Destroy Your Engine in 1 Minute.
Right, yeah.
Hopefully that'll grab a few people, and the subject is detonation pre-ignition. How to detect them, how to protect your engine from them, and how to stop the engine from being destroyed in 1 minute, which is exactly what that can do. So those are the upcoming webinars, and just to remind you that when Tim hits the button to end this thing, you're going to be taken to a survey, and one of the things that you will have the opportunity to do on that survey, besides say whether you love this or hated this and why, is to check a box that will let you subscribe to my monthly newsletter, which is all about maintenance stuff, and it typically comes out about the middle of each month by email. And of course, you can subscribe to it. If you don't like it, you can unsubscribe. There's an unsubscribe link on every issue. But if you're interested in getting the monthly email, you can just check the box on the survey. Hopefully, that'll be an incentive for you to actually take the survey. So that's all I have. Tim, and I guess we'll see everybody in a month.
Wonderful. Well, thank you very much, Mike, for volunteering tonight and sharing your information again with us. Very informative, as always. Thank you so much. And to all the attendees, thank you so much for tuning in tonight, and have a great night, everybody.
Yeah, thanks, everybody.